All right, here we're going to begin a little check-in sheet here. You guys know your big three functions here: linear, exponential, and quadratic. We also have these other functions over here: cubic, cube root, absolute value, and square root. We've learned those throughout this unit. Let's do a practice problem set. What I want you to do here is I would like you to attempt each problem. We'll go one by one, pause the video, and then press play because we're really not doing anything new. So this is a chance for us just to check in with you and see how you're doing. All right, so we're going to start off with number one. Go ahead and pause the video and press play when you're ready. All right, so the first thing that you'll realize is that we are multiplying to get from one number to the next. We're actually multiplying by 3. And when we multiply by 3, that's a common ratio, so this first function is exponential. Awesome, hope you got that. All right, so moving on to the second one. We want to look at these outputs from the top down, and what we notice is it's going down. It has a difference of 16 here, a difference of, let's see, 21 take away 9 is 12, and then 8. And so we notice that that's not linear. If it were linear, it would have a common difference. This is quadratic because what we notice is the second difference is steady at 4. And when it has the same second difference, we know that that is quadratic. This is quadratic here. Okay, go ahead and pause the video and move on to the second one, and we'll see if we can get this next one. All right, so if you're looking at the second one, what we need to do is plug these pieces of data into our calculator. I have done the same. I am just going to graph this thing. And if I did a very quick sketch, it looks like it's going to be, it's got a point, and it kind of comes up, and then it gets high, and then it starts working its way back down. So it kind of looks like this if we were just to think about it. Now, I'm not going to do this for real, but if we wanted to, we kind of see that it's got this parabola shape to it. So that's important to realize that the data here is going to be somewhat quadratic. So we're going to use stat calc number 5, and that's going to be our quad regression here. Rounding to the nearest tenth, y is equal to negative 5.1 x squared plus 298.8x minus 1,811.7. And that ends this question. There is your quadratic regression model. All right, let's move on to number 3. I want you to solve all of these equations and then press play when you think you have an answer. All right, we know that when we have absolute value, we're going to have 2 equations. The first one is as is. And we're going to solve that. I'm going to subtract x on both sides. I get 3x, add the 1 over equals negative 6. And then we're going to get our value here. So we're going to divide out the 3, and I get negative 2. So one of my solutions is negative 2. Now the other equation is 4x minus 1 is equal to negative x plus 7. Remember, negate that right side of the equation. If I add x, I get 5x, and I'm going to add 1, I get 8, and x is 8/5. Now it's important to always check these solutions. And so if you were to go ahead and plug both of these back in, they're actually both going to reject. This is going to reject, and this is going to reject. I can see that right away because on the right side here, for both of these, I'm going to get a negative value, and absolute value cannot be negative. So this has no solution. There's no solution here. All right, moving on to letter B, we have the 3 times the square root of x plus 7 plus 2 equals 17. We're going to isolate the absolute value here. So we're going to move the 2 over to be 15. Divide out the 3. You're going to get x plus 7 equals 5. And to get rid of a square root, we square both sides. So x plus 7 equals 25. And then if we take away 7 from both sides, we're going to get x equals 18. And that is the solution. We're going to plug in 18 over here for this x. That gives us the square root of 25 is 5. 5 times 3 is 15, and 15 plus 2 is 17. So that one checks out very nicely. Let's move on to our quadratic function that we're going to solve. Now this one I have to move the 1 first. So I have x minus 7 squared. X minus 7, let's go up higher. Squared is going to equal 9. I'm going to square root both sides, so I'm going to get x minus 7. X minus 7 is going to equal, that's going to be a plus minus here, is going to equal plus or minus 3. Remember, when you have to take the even index, when you square root both sides, it's a plus minus. If you take an odd index, you don't need that plus minus. So here we're going to get x equals 7 plus or minus 3. That's going to give us two values of 10. Or another value of 4. 7 plus 3 is 10. 7 minus 3 is 4. If I plug those in, 10 minus 7 is 3. 3 squared is 9. 9 plus 1 is 10. That one works. And then if I plug in 4, I get 4 minus 7 is negative 3. Negative 3 squared is 9. 9 plus 1 is also 10. So both of these check out nicely. And now we're going to move on to our last and final equation. So what we need you to do is attempt this by cubing both sides. So we're going to get x plus 1 is equal to 8 and x equals 7. It appears as the only solution here would be 7. And if I plug in 7 for this x, I get 7 plus 1 is 8. Cube root of 8 is in fact 2. So that one does check out as well. So that one's fairly simple there. All right, so everything worked out very nicely, other than letter A, which had 2 rejected solutions, so be careful there. All right, number 4, state the domain of the function. So we are going to go through this one real quick. Here we go. What I know is that I'm not allowed to square root negatives. That's not going to produce a real number. So I know that this inside the radical has to be positive, greater than or equal to 0. So I want to take this function and do the 10 minus the x has to be greater than or equal to 0. I know that that number, whatever's inside, cannot be negative. So I have negative x is greater than or equal to negative 10. And that's going to give me x is less than or equal to positive 10. Remember, when you divide out a negative, I'll show you here real quick. We usually don't show these steps, but we will. You're going to get x on the left side, flip the inequality sign to be less than, and make that negative divided by negative is a positive. So I know that the domain is everything less than or equal to 10. And you could also plug this in a calculator and go to the graph or the table of values to solve this that way as well. All right, moving on to number 5. Given the parent function f of x equals absolute value of x, describe the transformation to the new equation. G of x equals, and you guys can see it. So let's just get to this one right here. So the first thing I realize is that there is a vertical something. I don't know if it's a compression or stretch because I got to look at it carefully. Now you might say, oh, it's a fraction, so that's a compression. Be careful, that fraction is bigger than 1. 3/2 is larger than 1. So that's actually a vertical stretch. That's actually a vertical stretch. And the factor is 3/2. You also have a reflection over the x-axis. You also have a shift of, we're going to go left 9 and down 5. So those are the 4 transformations that take place: a vertical stretch, factor of 3/2, a reflection of the x-axis, and it's going to shift left 9 and down 5. All right, let's jump into number 6. Pause the video, write out the equations for these, and then we will see how you did. All right, so the first one I realize is that this is a cubic function. All right, so the parent function is going to be y equals cube root, so x cubed, sorry. So y equals x cubed. Now I immediately see that this point here was shifted left 1 up 5. So I know that I have an a value because I don't know if I multiplied it by anything, but it's going to go left 1. So that's going to be x plus 1 to the third. And I know it also went up 5. That's that middle point that we talk about. So it goes up 5. The problem is I got to figure out what a is. So I need to take another point. I'm going to choose this point here of 0, 2. This point here is 0, 2. So let's get that on here. And I'm going to plug that point in to this. So 2 is my y value. A is unknown. 0 is what my x value is. And that's going to give me 2 equals a plus 5. So a is negative 3. And so my final equation is as follows. Y equals negative 3. X plus 1. X plus 1 cubed. And then we are going to finally add that 5 on the end. If I can get this to work, would be great. Okay, and so that is the first one here. Looking on the next one, I noticed that this is a absolute value. This is an absolute value, which means what? It means that the parent function is y equals absolute value of x, right? Well, let's look at the turning point for a second. Look at this turning point. It's at 0, negative 6. So let me just jot that down. 0, negative 6. That's important, right? So what does that tell me? Is that there was a shift of down 6. So that immediately takes my parent function to be something like this. We have y equals, now there's an a value, of course. We don't know what that is, but I know it went down 6. And it didn't go left, right at all, so I'm going to leave that as absolute value of x. I'm going to plug in another point. Now let's just choose any random point here. I'll take this point right here, and that looks like it is 4, negative 7. 4, negative 7. We're going to plug that point in, and we're going to see what we get here. So 4, negative 7. So negative 7 is here. This is 4. This gives me negative 7 equals absolute value of 4 is 4. So 4a minus 6. I think it is going down by 6, right? So if I add 6 to both sides, I get negative 1 is going to equal 4a. And then negative 1/4 is the value of my a. So my equation is as follows. Y equals 1, negative 1/4. Absolute value of x shifted down 6, so that's minus 6. And we are done with that equation. All right, let's move on to number 7. Going on to number 7 has me determine the average rate of change for a function, a cube root function, over the given interval, negative 7 to 0. So I am going to plug in negative 7 and see what I get as my output. So I want to find f of negative 7. So let's just see what we get here. We have cube root of negative 7 plus 8. That's the cube root of 1, which is 1. So my first point is negative 7, 1. Now what I want to find as well is I want to find f of 0. So let's plug in for f of 0 is the cube root of 0 plus 8. Cube root of 8 is 2. So I have 0, 2. Now, we know that the slope is not constant on these functions, so we find the average slope, average rate of change, and so we are going to use our slope formula, delta y over delta x. And so that's going to give me 2 minus 1 on the top and 0 plus 7 on the bottom, and that's going to give me a slope or an average rate of change of 1/7. All right, let's move on to the next one. Again, keep pausing the video and keep trying these before we go over them together. Write the equation of a square root function that has been vertically stretched by a factor of 7. square root. So we're going to start off with this guy, the square root of x. He's our parent function, and we are going to transform that function by stretching it by a factor of 7 and then moving it 9 down, 14 to the right. So our new function will be as follows. We're going to have y equals vertical stretch a factor of 7. Now, if I want to go 14 right, I'm going to have to minus 14 on the inside. And then to go 9 down, I'm going to do 9 down, not in the absolute value symbol. And that is the equation there. All right, we are looking at number 9 now. So we are rolling here. G of x equals negative 3x squared minus 24x plus 5. And I need to determine the transformations that were applied to the parent functions. So I need to put this in what is called vertex form. Now, this is not easy to do. We just started working with these types this week. So let's see if we can handle this together. First thing I want to do is I want to take my g of x, and I would like to factor out the negative 3. So that's going to be negative 3, and I get x squared plus 8x, and then the plus 5 is there. Notice all I've done was just take out a negative 3 of the first two terms. So negative 3 times x squared plus 8x. And if I distribute that, I end up with negative 3x squared minus 24x, so that's fine. What I would like to do in my next step is I would like to half it, square it, share it kind of deal. So I get g of x equals negative 3. Now half of 8 squared is 4. Half of 8 is 4, and 4 squared is 16. So I need to add 16 here. Now to offset that, I need to subtract something. Well, really think about it this way. You didn't really add 16. You really added 16 times negative 3. Now, if I distribute this negative 3, I really subtracted 48. So I have to add 48 to offset that. And then lastly, I get g of x equals negative 3. This factors to x plus 4 squared. And then this is going to be plus 53. Now I can see that the transformations were, let's see, we have a vertical stretch of factor 3. We have a reflection of the x-axis. And then we have our translation. So it's going to go 4, shift 4 left, and 53 up. And that is that number 9. So let's move on to number 10, and we shall answer these questions here. Go ahead and pause the video, and then we are going to go through this. All right, so we're going to graph the first one. We know it was shifted left 1, so negative 1, 0 is going to be a point. And for my table of values, I have 0, negative 2. I also have 3, negative 4. And I have 8, negative 6. And that's kind of just off the graph, which is fine. We don't need that many points here. So what we're going to do is we're going to graph a nice curve through these points. And we'll go towards this last point and put an arrow there. And that is done. So this is our function g of x. And they also want us to graph h of x, which is the basic cube root function. So this one's quite easy to graph. Square root function, I'm sorry. So we have 0, 0, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and so forth. So do it off this way. And that is my h of x. And what kind of transformations do I have here? Well, this is going to tell me there is a shift of left 1, which you can see. Left 1. And there was also a reflection over the x-axis. And lastly, there was a vertical stretch of factor 2. All right, let's jump into h of x and g of x in the next one. Now here's our cube root function. So I'll go ahead and pause the video and do this one, and then we'll get with you in just a second. All right, cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So that's like up here. And then the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2 here. So let's go to negative 2 over here. And this function is somewhat like this. If it curves through, let's see if we can get this in better here. Kind of curves up through those 3 middle points and shoots off at those ones there. So this is h of x here. And then we want to do the other function, which is g of x on the same plane. And before we do that, we can even describe the translation here. So we're going to say translate, which really just means a shift left or right, up, down. So this is going to go right 2, and up 3. So I can actually graph this fairly quickly without a table of values. I'm just going to take all of these points and shift them right 2 and then up 3. And I get a point here. Let me make that a little bigger there. I get a point here. And then if I take 0, 0 and move it right 2 and up 3, it's here. And then if I take negative 1, and I go right 2 and up 3, it's here. And then if I take this on all the way 1, 2, and then up 3, it's over here. And so I'm going to do my best to sketch this function for us. So here we go. It comes from over here, shoots up through the middle, and then it's going to shoot way out to these side here. And that is g of x. So it should look something like that. I know it's not perfect, but you get the idea. All right, let's talk about domain and range of these functions. So the domain of h of x, we actually already did the transformation, so I'm not going to rewrite that. But let's just talk domain and range. Domain of our first function is greater than 0, so from 0 to infinity. And the domain of the g of x function went from negative 1 to infinity because there was a shift left 1. The range started at 0 and went up to infinity. And this one starts at negative infinity and goes all the way up to 0. The beautiful thing about cube root functions is all real numbers for all your domain and range. They don't ever change, which is great unless we restrict it. So these are quite simple to follow. Just negative infinity to positive infinity. No restrictions on my cube root functions. All right, let's go to our last and final page here, and then we can wrap this up. All right, so number 11, algebraically determine. Oh, that word algebraically, that's going to get us. So here we go. What I want to do is I want to complete the square on both of these functions. So I'll start with the first one, x squared minus 10x plus 2. So I'm going to do it a different way. I'm going to move the 2 over first. Some people like to move it to the other side. And then I'm going to complete the square on the right side. So I have minus 10x here. So minus 10x. We'll get there. And then I'm going to add a number. That number I'm going to add to both sides is half of 10 squared is 25. So I'm going to add 25 to both sides. So f of x plus 23 is equal to x minus 5 squared. And so f of x is equal to x minus 5 squared minus 23. So that one is done. Now let me jump on to the next one here, which has to factor out, unfortunately, a negative 1 first. So let's just factor out a negative 1 from that. So that's x squared minus 4x minus 7. I'm going to move that 7 over with the g of x. this is another way we could do it. We can move it to the left side. So -1. Now I have to think of a number that I'm going to add to both sides. That number is half of 4, which is 2. 2 squared is 4. Now, since I'm subtracting 4 on the left side, you might say, wait, it looks like you're adding 4. Well, be careful. You're actually subtracting 4 if you do -1 times 4. So I have to subtract 4 over here. Plus 3 is equal to -1 times x minus 2 squared. So I'm going to move that 3 over. So it's -1 times x minus 2 squared minus 3. All right, so the question was, identify the transformation. Well, we can immediately see that there is, number 1, a reflection over the x-axis. So let's write that down. We have a reflection over the x-axis. Now, let's look at the shift. So we went from -5 to -2. So we added 3 values inside the parentheses. So it's going to move left 3. It's going to move left 3. And then lastly, we're going to look at the number. So it went from -23 to -3. That looks like it goes up by 20. So we are going to go up by 20, and that's going to be the last part of this question. All right, let's move on to number 12. I want you to pause the video and graph f of x. It's an absolute value function, and then we'll do b and c together. So go ahead and pause the video, and then press play when you are ready to roll. All right, so I got my table of values out. I got my pen out. I'm going to graph -5, 4. That's up here. I'm also going to graph -3, 3. I'm also going to graph -1, 2. And then I'm going down to graph 1, 1. Then I have 3, 0. And then I'm going to start going back up now, I think. 5, 1, yep. And then lastly, 7, 2. And so my function is going to be a V shape, which we already know. And then we're going to kind of come up from this side, and that's going to go through there, nice and straight. So that is my function, which we call f of x. That is f of x right there. All right, so now let's answer the questions at the bottom here. State the domain and the range. Well, the domain of absolute value functions is all real numbers. So we have -infinity to infinity. And the range, well, there was no shift up or down, so it starts at 0, and then it goes forever up. The interval for where this is increasing is once it hits the vertex 3, 0, it starts to increase. So it's increasing when x is greater than 3. And it's decreasing when x is less than 3. All right, let's do our last question and wrap this up. So we have the graph of a transformation of the function x squared is shown. The transformation can be expressed as follows. We need to determine P, R, and N. So first thing I realized is that there was a shift of right 1 up 3. So right 1 up 3. So I'm going right 1, and then I'm going up 3. So that's going to take care of the R value and the N value. So I know that if I'm going right 1, the R value is -1. That would take it right 1, and the N value has to be 3 because it's going to go up 3. The last thing I have to do is figure out the P value, which is the thing I multiply by. That's going to vertically stretch or compress my graph. So to get that, I'm going to plug in a point. So let me just start with kind of a basic quadratic that went right 1 and then up 3. I'm going to plug in a point. 0, 1 is a good point to plug in. That is the y-intercept. It's always easy to choose that. That's going to be 1a plus 3. So if I subtract, a is going to be -2. So it is negative because it's upside down, which is important. So the value of P in this case is going to be -2. And that will conclude this. Have a great day.